Hey, Algebra 2, more trigonometry for you. Today we're going to talk about inverse trig functions. But before we get to what inverse means, we're going to refresh ourselves on some of our unit circle things. So you want to make sure that you have your unit circle out and ready to go. And you want to make sure that you copy down this table so that you can fill that in. Okay, so what we're going to do here is we're going to fill out this table. And if you remember in your unit circle that cosine is x, sine is your y value, and tangent is the y over x, or sine over cosine. So at 0 degrees or 0 radians, we use our unit circle and we say, okay, here at 0, what point is that? Well, that's the point 1, 0. So cosine is 1, sine is 0. So the cosine of 0 is 1. The sine of 0 is 0. Whether we're working in degrees or radians, it does not matter. And the tangent of 0 is y over x, or 0 over 1, which is 0. Okay, how about 30 degrees and pi over 6? So here we find 30 degrees and pi over 6. X is root 3 over 2, and y is 1/2. So we can fill that in. X is root 3 over 2, which means that the cosine of 30 degrees is root 3 over 2, or the cosine of pi over 6 radians is root 3 over 2. The sine is 1/2, and the tangent takes a little bit more work. The tangent's going to be y over x, or 1/2 divided by root 3 over 2. And of course, we're so good at fractions that we know we do 1/2 times 2 over root 3. And we cross cancel, and we get 1 over root 3. We know we can't have a root on the bottom, so we multiply by root 3 over root 3. And we end up with the square root of 3 over 3. Good. Now 45 degrees and pi over 4. So at 45 degrees and pi over 4, our x and our y, our cosine and our sine, are actually the same. They're both root 2 over 2. So we fill in here the cosine of 45 degrees is root 2 over 2. The sine of 45 degrees is root 2 over 2. The tangent of 45 degrees is root 2 over 2 over root 2 over 2. Or this over this, root 2 over 2 divided by root 2 over 2. Anything over itself is 1. So the tangent is just simply 1. Then we have 60 degrees and pi over 3. So we go here and we have 60 degrees and pi over 3. X is 1/2, or cosine is 1/2. Sine is root 3 over 2. Okay, so the cosine of 60 degrees, or the cosine of pi over 3, is 1/2. The sine of 60 degrees, or the sine of pi over 3, is square root of 3 over 2. Notice that's the opposite of 30 degrees and pi over 6. So the tangent is going to be the opposite also. So if we write it out long ways, we're going to say root 3 over 2 divided by 1/2, which is y, divided by x, or y over x. So we have root 3 over 2 times 2 over 1. 2's cancel, and we get root 3. Notice these are opposites because the x and the y, the cosine and the sine, were opposite. So this is just root 3. Now at 90 degrees, or pi over 2, we have x is 0, y is 1. So the cosine of 90 is 0. The sine of 90, or the sine of pi over 2, is 1. And the tangent is y over x. So the tangent is 1 over 0, which is undefined. We can't have that. We cannot divide by 0. So the tangent of 90 degrees, or the tangent of pi over 2, is undefined. Okay, so keep this handy, and we'll do some problems here. So this right here is the table that we just filled out, and we know how to read this, of course, as the sine of 30 degrees equals the square root of 3 over 2. So if I gave you the sine of theta, the sine of some angle is square root of 3 over 2, you could look over here at your table, you could look under sine, and you would find square root of 3 over 2. And you would say, okay, so the sine of 60 degrees, or the sine of pi over 3, is square root of 3 over 2. So you would be able to find that theta measure. In degrees is 60 degrees, and in radians is pi over 3 radians. And we're going to want both answers here. Okay, then we have the tangent of root 3 over 3. And so if we need that, we're going to look at tangents, and here's root 3 over 3. Okay, so then that angle must be 30 degrees, or pi over 6 radians. And then if we have the cosine of theta equals 1, and we need to figure out what theta is, we know that when the cosine is 1, theta must be 0 degrees, or 0 radians. Okay, so what you are doing there is working backwards, and that's called the inverse trig functions. You are doing the inverse here even though you haven't heard of it yet. We write it though a little bit different sometimes. Sometimes you'll see it like the sine of theta equals square root of 3 over 2. Sometimes it will look like that, and your job will be to find theta. Sometimes it will look like this. Number 1 and number 4 are the exact same things. Okay? They're asking the same question. The inverse sine of root 3 over 2 is 30 degrees. And here you'll see the words of how to say that. The inverse sine of the square root of 32 is 30 degrees. If you have the inverse sine or the inverse tangent or the inverse cosine, that means you are looking for the angle measure in radians and degrees, or degrees depending what the directions say. So in number 4 we have inverse sine of root 3 over 2. We've already done that. We know that the sine of 30 is root 3 over 2, and therefore the inverse sine of root 3 over 2 is 30 degrees, or pi over 6 radians. Okay, so now we have number 5, which is written in our new form, and again this is called inverse tangent of root 3. So over here we find inverse tangent root 3. We look for root 3, so that angle measure must be 60 degrees, or pi over 3 radians. Similar for inverse cosine of 0. Make sure as you read this you're saying it correctly in your head. Inverse cosine of 0. Here's where cosine of something is 0, and that's 90 degrees, or pi over 2 radians. Seems pretty easy, right? Good. So, unfortunately, you don't get this table. You need to know and be able to use your unit circle. Okay, but it's not much of a stretch, because what we did was we used our unit circle to create our table, and then we used our table to answer the questions. Now we need to figure out how to skip that table step and just use our unit circle. So again, what's really, really, really super important to know here is that your x value is your cosine of theta, your y value is your sine of theta, and your y over x is your tangent of theta. So in number 1, we want the inverse sine of root 2 over 2. Inverse sine, that means we are looking for the angle measure, and we're going to want them in degrees and radians. So we're looking for the angle measure there, where y, because sine is y, is root 3 over 2. So we use our unit circle to find root 3 over 2. By the way, we are not using anything but quadrant 1. Okay, so we can focus on quadrant 1 here. And we need to find root 2 over 2 in the y area, which is right there. So this is 45 degrees, or pi over 4 radians. Okay, so inverse cosine of 1/2. Change up colors here. Inverse cosine 1/2. Cosine is x. So we look over here, we find which x is 1/2. There it is. So that's 60 degrees or pi over 3 radians. Still pretty easy until, unfortunately, when we get to tangent. Okay, because tangent's not very simply put onto our unit circle. So where is the inverse tangent of 1? Which angle has a y over x equal to 1? Okay, so you should be drawn maybe a couple places. Your axes, your 0 degrees and your 90 degrees, those have some 1s in there. But so what's the tangent on each of those? Well, this is 0 over 1, that's 0. This is 1 over 0, that's undefined. So it's not any of those. So where is the tangent 1? Well, if you look right here, x and y are the same. So y over x here will be 1. So this is 45 degrees or pi over 4 radians. Okay. What about inverse tangent of root 3 over 3? Hopefully you have an idea of where to go for this. Hopefully you've done enough of these and you start to just naturally memorize that you know that we're either looking here or here. Okay? Hopefully you figured out that it's not 45 degrees, it's not your axes, it's got to be one of those two. So just a real quick division will help you figure out which one. So if we take 60 degrees or pi over 3, we take that one first. We're going to do root 3 over 2 divided by 1/2, or root 3 over 2 times 2 over 1, which is root 3. And I found it on the first try. That is 60 degrees or pi over 3. If I was wrong, I would have gone ahead and tried the 30 degrees, the pi over 6, to see what came up there. So for your video examples now, I want you to finish 5, 6, 7, and 8, and we'll go over them tomorrow. Have a great day.